Greetings, Mathies. Today we are going to take some notes on combining like terms. But first, the Laffy Taffy jokes. All right, let me get my screen set up and we will get going here. All right, so go ahead and get your notes out, and I'll get the screen ready here. All right, so we just have some fill in the blanks to put in, and here it is, combining like terms. Okay, so like terms are elements of an equation that match. Now there's two different types of terms that we have. We have constants and we have variables. So constants only match with other constants. And examples of those would be any number, 7, 10, -3. Non-examples would be 7x, -8x. Variables only match when they have the same variable and exponent. Okay, so some examples of variables that do match would be 3x and 7x, 2a squared, and 6a squared. So some non-examples would be like 2b and 2a. Different letters, they don't match. 3x and 4x squared. This one would be to the power of 1. This one would be to the power of 2. So these do not match. Okay, so combining like terms. So like terms can be combined or simplified by adding or subtracting. Terms must have the same variable and the same exponent to be combined. The commutative property allows us to rewrite the expression in a different order without changing the overall value. All right, so we have 5 great examples just to go over with you. So when I look at number 1, I see that both the terms are just a terms, 3a plus 4a. So I know I can add those together. So I look at the coefficients, they're both positive. So 3a's plus 4a, that's going to give me 7a for an answer. So that is just a one-term answer. When I look at number 2, though, I can see, okay, I have y terms and I have a constant. So that signals to my brain, I'm going to have 2 terms in my final answer. Now, I like to underline. I've seen some kids draw arcs. Some kids like to use highlighters. So you do whatever you need to do with this. 7y minus 3y, that simplifies to 4y, and we still have that constant of plus 2. Number 3. Again, I'm looking at it. I have x terms and I have a constant. Don't forget about the invisible one. We have those a lot of times in math, so that means we have 1x. I'm going to underline those like terms. 3x plus 1x is equal to 4x. That constant is minus 4. Last 2 examples. Okay, I see that I have a letter S and I have some constants. So I am going to underline my S's, -3s plus 6s. So when I have opposite signs, I know I need to subtract and keep the sign of the number that's furthest away from 0. Well, 6 is furthest away from 0, so I know my answer is going to be positive. Negative 3s plus 6s is positive 3s. And then I have my constants. I like to circle them. You do whatever you need to do there. 5 minus 8. So again, I'm thinking 5 is positive, 8 is negative. They're opposite signs. I'm going to subtract them, and I know negative 8 is further away from 0. So when I subtract them, I get 3, but I know it should be negative 3. Last example. All right, now I have some x squareds and I have some x's. I like to do a double line because it's to the second power. Don't forget about that invisible 1. 4x squared plus 1x squared is 5x squared. Negative 3x plus 5x. Again, those are opposites, so I have to subtract them, give the sign of the number that's furthest away from 0. And I know 5 is further away from 0 than negative 3. So my answer is going to be positive 2x. All right, now what I need you to do is cut the lines. So get rid of this excess, and you will glue this into your notebook.